So this is analytic geometry is the topic I'm starting with. Okay. And so this first one was the equation of a sphere with center 0, 1, minus 2, and radius 9. That's the question, and the general equation for a sphere is this. Where the center, so I guess this is in the equation sheet that you get, is that h, k, and l, and the radius is r. And so substituting, you get and I think all of these problems that I took out of the various documents you provided to me had multiple answers you could choose from, and so, but I'm just showing you the one correct answer. So that's my first analytical geometry one. And the next one is a general geometric shape defined by that equation, and the question is what type of curve is this? Hard to tell by looking at it. This has to do with conic sections. Could be a circle, an ellipse, a parabola, a hyperbola, and so looking at the general equation of a conic section, you identify that A is 2, B is 8, and C is 8, which are these first three coefficients. So the general equation being ax squared plus bxy plus cy squared, and so on. And with those three coefficients, we calculate this discriminant, which discriminates between the different types of curves. And so we get 8 squared minus 4 times 2 times 8, and that is 0. Yeah, 0. And when that discriminant is equal to 0, the section is a parabola. Okay, move on. So my third analytic geometry problem is the foci of the curve defined by that equation. So what are the foci of that? that equation. And with that minus sign, that is a hyperbola. With the center at the origin. If you look at the general equation for a hyperbola, which again is in the equation sheet, you can identify that as being a hyperbola with the center at the origin. And the general equation for a hyperbola with center at the origin is x squared over a squared minus y squared over b squared equals 1. So a squared equals 9, b squared equals 16. And the foci are at plus minus a times e, where e is the eccentricity. And that's defined as the square root of 1 plus b squared over a squared. So that's square root of 1 plus 16 over 9, which turns out to be 5/3. And so the foci are at plus minus AE, which is plus minus 3 times 5/3, which is plus minus 5. I guess let me come back here and add to this. Those are the x-coordinates of the foci, with the y-coordinate being 0. So the x-coordinate is what we just obtained. So the foci are minus 5, 0, and 5, 0. Right, since there's two foci for a hyperbola. In fact, this question had multiple, it's a multiple choice question, and you could choose more than one answer. So there were 2 answers in this case. Just a good pace. Too slow, too fast? I'll do one more for analytic geometry, which is slope of the line perpendicular to y over 5 plus x over 10 equals 1. So for this, putting it in the standard form, y equals mx plus b, we get y equals, multiplying through by 5, we get what, x over 2 5, so y equals minus x over 2 plus 5. So the slope m of this line is minus 1/2. The slope that's perpendicular to it is the negative of the reciprocal of the slope of that line, so minus 1 over minus 1/2, which is 2. So the perpendicular slopes. Bringing back memories? All right. Now we'll do some calculus. The first one I have is a typical calculus problem. The curve y equals 3x squared, and we want the area between course, the integral of f of x dx, which here is 2 to 5 of 3x squared dx, which using the tables in the equation sheet document, let me get this, x cubed over 3 for the integral of x squared dx, and putting in the limits, you get what, 5 cubed minus 2 cubed, and that turns out to be 117. Too easy? All right, well, a list of integrals. What's that? A table of integrals. Just a list of a bunch of general integrals. So the integral of x to the n is x to the n plus 1 over n plus 1. All right. Number 2. What is the x value corresponding to the only point of inflection, POI, on the curve y equals x cubed plus x squared minus 3. Yeah, so it's cubic. It generally has one point of inflection, and to determine that, we take one derivative to get the slope, so 3x squared plus 2x, and again, derivatives or tables of derivatives in the equation sheet you'll be given. And then the second derivative is 6x plus 2, and the point of inflection, in that direction. So the point of inflection is when 6x plus 2 equals 0, or x equals minus 1/3.
So always when you find the point of inflection for any equation, so as the second derivative.
Not where the slope is 0, no, right? The slope is 0 is a max or a minimum. Slope's the first derivative, yeah. So that gives a max or a min, and what we need is a second derivative here to find where the curvature, the rate of change of slope, is 0. So it's not concave up, it's not concave down. It's transitioning from concave up to down, or vice versa. All right, we want a little more challenging for Amelia. This will be 3 for calculus. You want the limit as x goes to 0 of 1 minus e to the 3x divided by 2x. So if you substitute in x equal to 0, for x equal to 0, you get 0 over 0, undefined. And so you can't directly obtain that limit. Rather, you have to use L'Hopital's rule. It says that that limit can be obtained also by taking the derivative of the numerator and the denominator. And so this limit is the same as the limit as x goes to 0 of the ratio of the derivatives. So that's what? Minus 3e to the 3x divided by 2. And now you can substitute in x equal to 0 and we get minus 3 halves. It's the final result. And again, that derivative that I took of the numerator is in the tables.
I forgot how limits work. I brought that.
All right, so that was a good one. Okay, so let's do this one for the last calculus one we'll do here is the area bounded by y equals x squared and y equals 0. I'm sorry. Y equals x squared y equals 0 and y equals 4. So if you plot that, here's y equals x squared. Here's y equals 4. And I guess what this is trying to say is it's the area under here rather than the area above that curve. I guess that's what the specifying the y equals 0, which is the x-axis. So it's that area, and so we could use, we have a choice of using horizontal or vertical strips to do this integration, and so using horizontal strips, this is some general y value, and the corresponding x value from here is plus or minus the square root of y. And it could be positive or negative. So the area then is, using those horizontal strips, since we have symmetry there, we could do half of it multiplied by 2, so we'll do 2 times the integral from 2 times the integral from 0 to 4. Right? This was y equals 4. And the area of our strip is this half, which is plus the square root of y, and the width of it here is dy. So that's that integral, which is y to the 1/2. So we add 1, that's y to the 3/2, divided by 3/2, so we'll multiply by 2/3, and put the limits from 4 to 0, and the whole thing is multiplied by 2. So substituting in the limits, we get 2 times 2/3 times 4 raised to the 3/2. which is square root of 4, which is 2. 2 cubed is 8. 2 is 16 times 2 is 32 divided by 3. That's our final result. So that's using horizontal strips. You could use vertical strips as well, in which case the height of the strip would be 4 minus the y value, and the y value is the same as x squared. So you have 4 minus x squared times dx is the width, and then you'd integrate from 0 to whatever value this has when y equals 4. So we take that extra step of finding out what that x value is, so you would integrate your vertical strips from here over to here and double it. Any questions on that?
So you take during the vertical ones, you just subtract the negative space.
Let me just show the setup for that. So now we have a vertical strip with width dx. The height here would be 4 minus the value of y here, which is x squared. And then the integral would be, for the area, the integral would be 2 times the integral from 0 to this value. And when y is 4, we have y equals x squared, so when y is 4, then x is 2. So the value here is 2, so we integrate to 2, and we'd have 4 minus x squared dx. And that will equal 32/3 if you work it out. Yeah. So that's calculus, and I think a little more challenging topic is roots of equations. So one type of question you might get for roots is you're given a function, cubic here, which generally may have what? One root, one real root. In case it might look something like this. One real root, or three real valued roots, but one is a repeating root, or you might have the final case of 3 real roots. And one type of question you might get is, given a function, which value is a root, and then give choices here. So in this particular problem, it was a multiple choice with 2, 3, 4, and 5. So this function is, you could define it as f of x equals x cubed minus 8x minus 3, and then plot it, and then set it equal to 0. And that's where it has its roots, where it crosses the x-axis. So in this case, you'd have one real root, here you'd have 3 with 2 of them repeating, and here you'd have 3 distinct real roots. And so if one of these values is a root, then it satisfies this equation. So the easiest thing to do is just to substitute each one in and try it. So for A, you'd get 8 minus 16 minus 3, which clearly is not 0. For B, you get 27 minus 24 minus 3, which is what? That's 0, I think. So that's the answer, B. So it's a quick, easy way is just try it and see if it makes a function equal 0. But that's in concept what you're doing. You're finding those locations of the x values where the curve crosses the x-axis. that's one root problem. This is an interesting one. So the second root problem is, what is the function? Notice that on this previous problem, in this first case, we cross the axis once, but it's a cubic. So there are three values for x that make this equal to 0. Two of them are complex value, because we have only one point where we cross the x-axis. So in this case, this question is, what is the function whose roots are -1 plus I and -1 minus I? So two complex valued roots. So two roots, suggesting that the function is a second order polynomial or a quadratic. So you could have a quadratic, say, that looks like this, and it crosses at 2 points, and there's two real valued roots. Or it could cross, say, you could just hit the x-axis, so there's two real roots that repeat. Or another possibility is that it doesn't cross at all, and so there's two complex valued roots. So that's the case here. And in general, if A and B are roots of a function f of x, then you can write f of x as x minus a times x minus b and set it equal to 0. Right? Since when x is a, this will be 0, and when x is b, this will be 0. And so we can write the function as that product of x minus a and x minus b. And if we're saying these two are roots, then we can assign one of those as a and one of those as b. So we would get f of x equals x minus 1 plus I multiplied by x minus 1 minus I. And what is that? That's x plus 1 minus I times x plus 1 plus I. And if you, let's see here, if I rewrite that as x plus 1 minus I in parentheses and x plus 1 plus I in parentheses, and we can square that, or multiply it together, I should say, and we get what? X squared, f of x equals x squared plus 1 minus ix plus 1 plus ix plus 1 minus I times 1 plus I. And then simplifying that, we get plus x minus ix plus x plus ix. And then multiplying this out, we get 1 minus I plus I, and I squared is minus 1. And multiplied by a minus sign, we get a plus 1. So we're remembering that I squared is the square root of minus 1 squared, which is minus 1. So here we're using, I should have said this at the beginning, we're using I as the imaginary unit. And so we have what? We get some things that cancel out here. That goes out, that goes out, that goes out. And we finally have x squared plus 2x plus 2. And that's it. That's the function. Maybe we'd say f of x equals that. No, I wrote that f of x equals that. And so if you were to plot that, you'd see that it doesn't cross the x-axis, and that's why the two roots are complex values. And then I'll do a few vector problems. I think at least going through these gives you a sense for the level of difficulty of the problems, or non-difficulty, however it may be. But I have a few problems relating to vectors. So the first one here is, what is the unit vector? Do you guys have any questions about the previous problem we just did? No? Okay with that? The unit vector perpendicular to the plane defined by a vector A that's 2i plus 4j and a vector B that is I plus j minus k. So this is in three-dimensional space. We have a plane that's characterized by these two vectors, and we want a vector that's perpendicular to that plane, and it's a unit vector. So the approach here is to get a vector perpendicular to the plane and then turn it into a unit vector. So a vector perpendicular to two other vectors is defined by the cross product of these two vectors. Their cross product will be perpendicular to the plane that defines the two vectors. And so A cross B means 2i plus 4j crossed with I plus j minus k. You could carry this out easily by just distributing, or you can write it as a determinant. And if we have two vectors with three components, I, j, and k, and then we define the coefficients of those three vectors and take that determinant, we get the same thing as distributing the 2i and the 4j with the other vector through cross products. And so this, to evaluate this determinant, we repeat the first two columns, and then use the diagonals in this direction to get minus 4i plus 0j. I'll write that out just to show it. 2k, what happened now? What did I do now? Oh, move the mouse? There we go. All right. So I did the diagonals down and to the right, which have positive signs associated with them. So minus 4i plus 0j plus 2k.
Why is it minus 4?
The 4 times the minus 1. Yeah. And then I'm going to go in the other direction with these diagonals and with minus signs. So minus 4 times 1, which is 4k, minus 0j, I'm sorry, I, and minus a 2 times a minus 1, so that's plus 2j. So putting that all together, we've got, in terms of i's, we've got minus 4i. In terms of j's, we have 2j. And in terms of k's, we've got minus 2. Let's see if that's right. Yes. So that's a vector perpendicular to that plane. And now to turn it into a unit vector, we take the vector and divide it by its magnitude. So minus 4i plus 2j minus 2k divided by its magnitude, which is the sum of the squares of the component's square root. So we get 4 squared plus 2 squared plus a minus 2 squared I'll just write that as a 2 squared. That's what, 16 plus 4 plus 8, that's 24. That's the square root of 24. So minus 4i plus 2j minus 2k divided by the square root of 24. And simplifying it as what? 6 times 4, so we can pull out a 2. So divide all that by 2. So we get 1 over square root of 6. And then dividing all these by 2, we have a minus 2i plus a j minus a k. I'll write that final result more clearly as 1 over the square root of 6 times minus 2i plus j minus k. What was your question? Okay. And that's my final result. Yeah, it's common notation to use E as a unit vector. And here I had defined this as C arbitrarily. I could have also called it C hat. There's a hat indicates the unit magnitude. Okay, so another vector problem here is a so this would be number 2 for the vector analysis, and it's one that has 3 forces of magnitude 5 newtons, 2.12 newtons, and 2.12 newtons this way. This is an X and a Y axis. And the question is, what is the magnitude of the resultant force? And this angle here is 105 degrees. So there's a few ways to do this. One would be to define these as vectors A, say B, and C vector. And so the resultant vector is A plus B plus C in vector notation, where the vector A is minus, for the horizontal component, if we look at this angle here, it's 105 minus 90, so that's 15 degrees. So the sine of that angle gives the component in the x direction, so minus 5 times the sine of 15 degrees. And that would be in the x direction, or I hat, plus 5 cosine 15 degrees in the vertical direction of j hat. So that comes out to be something. I'll just leave it like that for now. The B vector is 2.12 j hat, and the C vector is 2.12 I hat. And so the resultant then is the sum of those three. So for the x direction, minus 5 sine 15 plus 2.12, all with an I, and plus 5 cosine 15 degrees plus plus 2.12j. So the question is, what's the magnitude of the resultant? And so we could write that as in this way, with bars on it, and we'd have the square root of rx squared plus ry squared, which is the square root of minus 5. Rather than writing that out, I'll just say that this first term is what I called rx, and which is the scalar value of r in the x direction, the scalar value of r in the y direction. We square those, add them together, take the square root, we finally get 6.99 and so on. And I think the solutions, or the multiple choice answers, included a value of 7 newtons. And I'd like to do one more vector analysis, which is the angle between two vectors. So we use the dot product. We already used the cross product. Yeah. So the question is, what's the angle between these two vectors? I hat plus 3j hat plus 6k hat, and b vector is 2I hat. So when you have done work in the past with vectors, did you use the hat notation?
Yes.
Okay. So again, the hat, like I said earlier, was when I had the e hat, was kind of unit vector in a general direction. All the I, j, and k with hats are specifically unit vectors in the x, y, and z directions. So the angle between them, we've got this dot product that says a dot b equals magnitude a, magnitude b times the cosine of the angle in between the two vectors. So we need the magnitudes and the dot product. And the dot product is easier than the cross product. We just multiply together the common components, and it's a scalar. It has no direction. So this will be 2 plus 12 plus 30. 44. All right, so dot product between two vectors, you multiply the corresponding components, and that's a scalar. And we also need the magnitude of A and the magnitude of B. Magnitude of A is the square root of 1 squared plus 3 squared plus 6 squared. So that's 36 and 9 and 1. So square root 46. And for B, the magnitude of it is 2 squared plus 4 squared plus 5 squared. 25 and 16. 41 and 4, 45, I think. 30 to 45. And so the angle theta then is the inverse cosine of A dot B divided by magnitude A, magnitude B. So the inverse cosine of 44 divided by square root 46 square root 45. And so that turns out to be points, or rather 14.8 degrees. And that is a quick overview of the math section of the FE exam.
Thank you.
You're welcome.
That sounds like man, this kind of
Yeah.